We're beginning a new unit. We are beginning Chapter 8. So Chapter 7, we skip over intentionally. We don't need Chapter 7 to be able to work through Chapter 8. And Chapter 8 specifically needs to be a part of Algebra 2. What's in Chapter 7, if you go on to take trig pre-calc, is also covered there. So we might come back to Chapter 7 at the end of the year. It's one of those, if we have time, we'll come back to it units. But if we don't get to it, it's fine, because we'll get to what we need to get to for Algebra 2. So Chapter 8, this is also a very small chapter. We only cover 3 sections. So we cover 8.1, 8.2, and then 8.6. And it's on, what we are working with, it's on rational expressions. So it's on rational functions and relations. We will not be graphing rational functions. We are working with being able to simplify and then add, subtract, multiply, divide rational expressions. That's our goal throughout this short unit. So I would say for sure you could expect the quiz next week and then probably the test the week after, although I know it's right around ACT time, so schedules will be different. But we'll get through this unit pretty quickly. It doesn't take too long. But it is important for you to understand how to simplify when you can simplify. Because a lot of the time I see students simplifying when you are not supposed to be. You're simplifying things that can't be simplified. So to start out, we're looking at how to simplify a rational expression. So first of all, what a rational expression is. So rational, we've seen that term before with rational numbers. Rational numbers are numbers that can be expressed as fractions, ratios. So a rational expression is also a fraction, but it's specifically a ratio of 2 polynomial expressions. So the polynomials we worked with in Chapter 5, you would have a polynomial in the numerator and in the denominator. And then this is explaining how to simplify rational expressions. So it says, because variables in algebra often represent real numbers, operations with rational numbers and rational expressions are similar. So just as with reducing or simplifying fractions, to simplify a rational expression, you divide the numerator and denominator by their greatest common factor, their GCF. Okay, so it gives an example of just simplifying a fraction like you've done before, a fraction that's just a number, and then a rational expression with polynomials. So if you had the fraction 8/12, to simplify, you may not write it out this way. You may not write 8 as 2 times 4 and 12 as 3 times 4, but you would probably look at 8/12 and say I can divide both 8 and 12 by 4. And when you divide each by 4, you would get 2/3. The reason you're dividing by 4 is the greatest common factor of 8 and 12. So it's a number that can be multiplied into both. So when you have rational expressions with polynomials, you're looking for that same thing. Now what I want to make clear, and I've said this before, if you just look at this expression as it is, you cannot cancel out the x squareds. So if you want to make a note to yourself, these x squared, and actually, I mean, this would be for all of these are each a term. You cannot cancel out terms. Terms are being added and subtracted to something else. You cannot cancel terms. You can only cancel factors, which are things that are being multiplied together. So what we're going to have to do, we're bringing factoring back. I told you it doesn't go away. You would need to factor both the top or the numerator and denominator if you can. So they are factoring x squared minus 4x plus 3. They're doing the diamond to get x minus 3 times x minus 1. And then they're factoring x squared minus 6x plus 5, again with a diamond, to get x minus 5 times x minus 1. And then notice they both have a factor of x minus 1. That's their GCF. So those cancel out, and you're just left with x minus 3, x minus 5. And again, in this answer, the x's are terms. They do not cancel to be 3/5. It stays x minus 3, x minus 5. That's the simplest form you can get it into. So we're going to go through some examples of simplifying these expressions. The directions also state, so it says to simplify, And then a second thing we're going to talk about, it says under what conditions is the expression, that should say is, not in. Under what conditions is the expression undefined? And that's an idea we've talked about in the last chapter, but we'll go through that here because it's worded a little differently. So if we look at, I know the A is cut off, but if we look at the first example, in order to simplify this, you can only cancel out common factors from the numerator and the denominator. So do you see anything right away that could possibly be canceled out in that first example? Do you see a common factor on the top and the bottom? So they both have a y, and this y is being multiplied, so you could cancel out those y's. Otherwise, they have no common factors. So then to know whether or not it is now fully simplified, you have to see, is there anything that you can still factor in the expression? And really what you want to look for when you have variables is if you see something squared or something to a power that's higher than 1, it's possible it could still be factored. So this y squared minus y minus 6, that is a trinomial. To see if we can factor it, we could set up a diamond problem. So to see if this factors, what would we be multiplying to? We'd multiply to negative 6 and add to negative 1. Are there two numbers that work? Yep, 2 and negative 3. Okay, so I'm going to rewrite this expression on the top. I still have the 4 times the quantity y minus 3 times the quantity y plus 4. But now on the bottom, I'm going to have, if I write this in factored form, and I can go straight to the factoring because the coefficient of the y squared is 1. This now factors to y plus 2 times y minus 3. And then I look at the top and the bottom, since now everything is factored. I see they have a common factor of y minus 3, so the y minus 3's cancel out. So the final simplified expression is on top 4 times the quantity y plus 4, on the bottom y plus 2. And that would be fully simplified. The y's do not cancel. Cora? Because they're factors then. So because the y minus 3's are being multiplied, it's in factored form, they have a common factor. It's the same reason these y's here canceled out. Yep, just because they're the same and they're factors, yep. All right, so then once it's in simplest form, to answer that second question, it says, under what conditions is the expression undefined? So this is similar in the last chapter, what you just had your test on, to say this is only going to be defined if the denominator is not 0. So the expression is undefined, if you want to make a note, when the denominator equals 0. So to figure out where it would be undefined, you would take your denominator, which for this example is y plus 2, and say y plus 2 cannot equal 0. And then solve the equation for the y value. So if I solve this for y, I would subtract 2. So this means y cannot equal negative 2. Okay, and I'm just going to add that after my expression. So this is the simplified expression as long as y does not equal negative 2. Okay, any questions on that one? Okay, we're going to go through part B together as well. So we have 3y times y plus 7 over y plus 7 times y squared minus 9. Anything right away that you can see would cancel out? The y plus 7. Yep, they both have a factor of y plus 7. Those can cancel right away. And then look at your expression. So the 3y is in simplest form, the y squared minus 9. That y squared is a hint to me that I could possibly factor this. How do you factor y squared minus 9? It's not the 0. Well, I guess you could set up a diamond for this. This is a special type I'm going to tell you about, but I do want to show you could set up a diamond for this. You're multiplying to -9 and you're adding to 0 because you don't have a middle y term. So what two numbers would multiply to -9 and add to 0? 3 and -3. So then I'm going to have 3y on top, and I would then have y plus 3 times y minus 3 on the bottom. So now it's fully factored. This, you could go straight from the y squared minus 9 to here if you recognize that that is a difference of squares. But you can also set up a diamond if you forget that difference of squares. That was that a squared minus b squared always factors to a plus b times a minus b. It's kind of a shortcut. But now that I have everything factored, is there anything more that I can cancel? Does anything more cancel out? I see some no's. This, nothing else cancels out. This is the simplest form. Okay, so then for this final expression, to say where is the expression then undefined, I would have to set the denominator equal to 0. Or rather say y plus 3 times y minus 3 cannot equal 0. And this means that to solve this, y plus 3 cannot equal 0, y minus 3 cannot equal 0. So then if I solve both of these equations, I get y cannot equal -3 and y cannot equal +3. So I have two conditions for this one. This is the expression. However, y cannot equal, and I could simplify this to say y could not equal plus or minus 3 if you just wanted to write it as 1. Or you could actually list both, y can't equal -3, y can't equal +3. Okay, so what I'd like you to do is answer part C, simplify that expression as far as you can, and then say where that expression is undefined. Or list the conditions, what can the variable z not equal. All right, when you're ready, because I know some of you are still working, just double check in case you weren't quite done when I walked around. So one comment, when you're simplifying, it's rare that you would ever need to distribute or to FOIL or to multiply that way. You're mainly looking to factor, the reverse of distributing or FOILing, so that you can cancel things out. So your goal is there anything I can factor? What can I cancel? And then if nothing else, like in your answer here, you do not need to redistribute the 2z. You could, but you don't have to. Okay, we're going to move ahead. For example 2. Example 2 asks a similar question to the second part of what we did under example 1. But notice I included this example for a reason. It doesn't say anywhere in the directions that you should simplify the expression. So what I usually see students do is they would read this question, simplify this, and then find where it's undefined. If it just asks you where is this undefined, do not simplify it. Simply think to yourself, it's undefined if the denominator is 0. So you can start out right away by just setting the denominator equal to 0 and then solving for x. But don't simplify first. Okay, so in this expression, what you could do, you don't want to distribute the -6 because the -6 is being multiplied. I could divide both sides by -6 to get rid of it. So it'll cancel out on the left side, and I'll just have x squared minus 3x minus 10. And then I still have 0 on the right side. 0 divided by -6 is still 0. And then I have a quadratic equation here. How do you solve a quadratic equation? Quadratic formula or factoring. Yes, so quadratic formula I do have up here. Yes, you can use it. Or you're going to be factoring a lot in this unit. If you can factor it, that might be simpler. So if we're factoring this, what are we multiplying to? And adding to -3. Does factoring work? What two numbers would I use? -5 and 2. And then again, because that number in front of the x squared is 1, this factors to x minus 5 times x plus 2. That's equal to 0. I can then solve by setting each of these factors equal to 0. So x minus 5 equals 0. Or x plus 2 equals 0. So where is it undefined? It's undefined when x equals positive 5 or when x equals negative 2. Okay, so that process we did in the previous example, just make sure, look at the directions closely. If it doesn't say to simplify, do not simplify first, because that could then alter what your denominator is, and then it would alter your answer. So if it just says, where is it undefined, set the denominator to 0 and solve for your variable. Okay? For example 3, so these are just simplifying. There's something a little bit different about these. So if I were to simplify part A, anything right off the bat that cancels? The way it's written, no. So then you're looking to see, is there anything I can factor? So look at the top. Could you factor the top? Is there anything you could do to factor to rewrite that? Yes, there is a GCF of Z. All right, so don't forget that factoring out a GCF is a method of factoring. So I can factor a Z out of the top, and I'm left with just x minus 4. Make sure you do include the Z, the GCF, with it. And then on the bottom, I have Z squared, and I have 4 minus x, which that x is to the first power, so I can't factor there. Now, one thing I could do is notice the z's. If I have a z to the first power on top and a z to the second power on the bottom, the z on the top is going to cancel out, and then I'll just have a z left in the denominator. It's like I'm subtracting the exponents, but it's going to stay on the bottom since the larger was on the bottom. And then the x minus 4 and the 4 minus x, are those the same thing? If it was x plus 4 and 4 plus x, then they're the same. With subtraction, they're not the same. However, you could make these the same if for one of them, and it doesn't matter which one, if you factor out a negative 1. So if I divide, I'm just going to do this on the bottom. If I divide the 4 minus x both by negative 1, I would then have so I have the negative 1 out front, I'd have a negative 4 and then a plus x, which I can rearrange negative 4 plus x to be x minus 4. Okay, so if these almost look like they're the same, if they're a difference and they're just switched around, what you can do is you can factor out a negative 1 so that they are the same, so that you're able to cancel them. So now these will cancel, the x minus 4s, but you have to make sure that you include the negative in your answer. So I'm just going to include the negative in front of the z here. And then since everything is gone on the top, what do I have on top? A 1. Okay, so I wrote this kind of weird. I'm going to rewrite it. So really, it's 1 over negative z, or I could write that as negative 1 over z like this, or I could put the negative on top with the 1. That doesn't matter, but this is the simplest form. And it doesn't say find where it's undefined, so we don't have to put the condition for this. Okay, so I want you to simplify part B. Simplify this expression as much as you can. Pencil. you'll be able to catch the rest of the examples on campus. All right, I'm going to talk through this one, check what you have. All right, so I need everybody's attention up here, please. For the top, you can factor that by factoring out a GCF of AB, and you're left with B minus 5. Your denominator is already factored. And then the B minus 5 and the 5 minus B, they are not the same, but if you factor out a negative 1 from one of them, they will cancel. So then you'd have a negative AB on top, 5 plus B on the bottom. This is important. You cannot cancel out these B's. The B on the top is a factor because it's being multiplied. The B on the bottom is a term. You cannot cancel out a term. You can only cancel out factors. No, it's okay, Lily. I need to stress it so that you understand why you can't cancel. I don't want you to start just canceling everything. Okay. Any final questions on part B? All right, one last set of examples. So This, I just want to review with you how you multiply and divide fractions. So that might seem silly, but I feel like anytime we get to fractions, it's like, okay, what do I do to multiply and divide these? So when you multiply fractions, we are now going to be multiplying fractions that include variables. You multiply the numerators and denominators. You just multiply across. You do not have to have common denominators. And then you have to make sure you're simplifying. All right, I need your attention up here, please. Ladies in the back, make sure you're paying attention. You can, when you multiply fractions, you can cross-simplify as well. So in this specific example, this 2 and 4, you could cross-simplify, divide both by 2. So you'd have 1 over 2. The 9 and the 15, you could cross-simplify, divide both by 3. So the 9 becomes a 3, 5 becomes or 15 becomes a 5. And then multiply across. 1 times 5 is 5. 3 times 2 is 6. So cross-simplifying might be helpful. When you divide fractions, remember that dividing by a fraction is the same as multiplying by the reciprocal. So if I am dividing by 6 over 35, I'm really multiplying by 35 over 6. You multiply by the reciprocal. And then once you rewrite it as multiplication, you just do the same thing we talked about over here. Okay, so now we're going to go through this if you have, because this explains the same thing, if you have variables with your expressions. This is my recommendation. There's not just one way to work through this, but this is my recommendation for how to work through it. Usually, I'll look at the coefficients, so the 6, the 21, the 15, the 18, and I will cross-simplify if I can. So 6 and 18, I could divide those both by 6. So I'm going to rewrite the 6 as a 1, the 18 as a 3. And then the 15 and the 21, I can divide those both by 3. So the 15 becomes a 5, the 21 becomes a 7. So then at least your coefficients are simplified. I could do that same thing with the variables, but then sometimes it gets messy. So then usually from here what I'll do is I'll multiply across the top and the bottom. So on top I have 1 times 7 is 7. And then for the variables, I have x, y, and a to the third. None of those variables are the same, so I'm just going to write them. Everything is multiplied on top. I'm going to put it in alphabetical order, though. So I have a to the third, and then I have x and y. And then on the bottom, I have 5 times 3 is 15. And for variables, I have a, b squared, x to the fourth, and y. Again, none of them are the same. So I'm just going to rewrite them all multiplied together in alphabetical order. So because I cross-simplified, my coefficients, the 7 over 15, that's already in simplest form. My variables, though, if you have the same variables on the top and the bottom, there's more you can do to simplify with properties of exponents. So I'm going to write my fraction. I still have 7 over 15. I'm going to start with the a's. If I have a cubed on top and a to the first on the bottom, remember you can subtract those exponents. So 3 minus 1 is 2, and since the higher exponent is on the top, I'm still going to have an a squared on the top. And then for b, I only have a b squared on the bottom, so that's going to stay on the bottom. For x, I have an x to the first on the top and x to the fourth on the bottom. So if I subtract 4 minus 1, that's x to the third. Since the x to the fourth, the larger is on the bottom, I'm going to have x to the third on the bottom. And then the y to the first and y to the first, those just cancel out. So this would be the simplified expression. 7a squared over 15b squared x cubed. So make sure you don't have the same variable written multiple times. If you do, that means you can simplify it more. Okay, questions on that one? And then for B, so this one, when you're dividing, so pay close attention to your operation symbol. When you're dividing, there's one additional step you have to do that you didn't have to do for multiplying. You have to rewrite this as a multiplication problem. So your first fraction will stay the same, 16mt squared over 21a to the 4th b cubed. And then write the division as multiplication. And then flip your second fraction. So now it's 7a squared b squared on top, 24m to the 3rd on the bottom. Okay, so rewrite division first as a multiplication problem, multiply by the reciprocal. Then you do exactly the same process as we did for A. So with the time we have left, we have 4 minutes. I'd like you to finish simplifying part B. I'll come around, I'll check, but I'll also pass out your assignment. With all of this review of factoring and properties of exponents, I know I stress the practice a lot. It's not going to get easier if you don't do the practice. So make sure you're doing that. You will have a homework quiz at some point next week. I'll let you know that on Monday. So finish simplifying this, and then I'll come around and check and pass out the assignment. All right, and then when you're ready, not all of you are done. You can check what you have for answer B.